Hi, my name is Marella Winikovic, and these are my teammates Alex, Tiffany, and Corinne. We are team slightly below average. So our overall project for this semester was to compete in a competition where we have certain tasks that we have to complete and we try to maximize our point total. The different tasks that we have to complete are deployment. We try to complete that successfully every time. We have to remove missiles, which are wooden cylinders on the track. We also have to protect the children, which are wooden blocks that sit in the center of the target on the track. Then we apply shrink rays and anti-shrink rays, which are magnetic darts. We're applying them to a rotating centerpiece and aiming for our specific color zone, which corresponds to our start zone in the track. Then we apply a magnetic sphere, which is called the moon, on top of the dome of the rotating cylinder. And finally, we try to egress, which gives us a point multiplier on our shrink rays and our moon delivery.
So for our final design, we chose a cart design in order to simplify all of the tasks and make our cart more efficient. So we have a delivery arm that implements tasks 2 and 3, which is putting the magnetic rod onto the centerpiece and putting the magnetic sphere onto the centerpiece into the same motion. And this makes everything more efficient and makes it easier for the Raspberry Pi to complete this motion. We have a 4:1 gear ratio to move the arm upwards because the motor is too weak to move the arm upwards by itself, and we needed to find a way to increase the torque. We have 2 mouse traps mounted on the sides of our machine to push out the 2 wooden cylinders that are on the side of the target, and there is an L-shaped slider on the back to push out the back wooden cylinder. Lastly, we have a quadrant switch that can slide up and down, and this is because all tracks are different, and so in order to hit the beacon to tell us which color we need to go into, we need a quadrant switch instead of levels in order to be especially accurate.
So if you look at this side of the display, you can see that our shrink ray / moon delivery arm, you can see that's powered by a motor, and as the motor turns, the gears on the motor as well as the delivery arm rotates as well, moving the arm towards the centerpiece. There's a little holder at the top so that we can reach the top of the dome and deliver our moon, and we also have 2 pipes at different heights so that if we feel like a team is targeting us with their anti-shrink ray in a specific zone, we can change which zone we decide to put our shrink ray in by putting it in a pipe at a different height.
So for protecting the children, we left a little space at the front so that the wooden cube can slide safely under there without being interfered with by the other mechanisms as they're triggered. For removing the missiles, the 2 side missiles, we have mouse traps on either side. And those have fishing line that are wound around this trigger for the mouse trap. The end of that fishing line is tied to this pneumatic so that when it fires, it pulls the fishing line taut and triggers the mouse traps. And that's dimensioned so that when this is making rolling contact with the centerpiece, those are lined up with the wooden cylinders as they should be. The rear is an L-shaped slider that is attached to another pneumatic, so when that fires, it pushes the wooden cylinder out. It used to be a mouse trap, but we had problems kind of getting the angle of launch correct on that, so we switched to an L-shaped slider. And then we made the cart 5 inches off the ground so that the 4-inch tall missile can slide under that and into the L-shaped slider without interfering with the cart being pushed over. So these are all the different mechanisms that we use to complete the tasks, and through multiple iterations we believe that these will help us maximize our point total. Thank you for listening.